Okay, this is from the practice skills test earlier this week, number 7. This is the inequalities with absolute value equations. First thing you need to do on these problems is get the absolute value by itself. So we need to move this 14 and this 6 to the other side. First we add 14 to both sides. This 4 will turn into 18. Then we need to divide both sides by 6, since that 6 is connected to the absolute value bars with multiplication. So we divide both sides by 6. 18 will turn into 3. Now the absolute value is by itself. Once the absolute value is by itself and this side is positive, you're going to find two solutions. The first one is just to copy everything you see without the absolute value bars. So literally identical, no absolute value bars. The second one, you flip the sign of that number so it becomes negative and you change the direction of your inequality and you copy what's inside the absolute value bars. And that's how we're going to find our two answers. Add 6 to both sides, that'll generate a 9, and divide by 3 to get this statement. Add 6 to both sides here, and divide by 3 to get 1. And then go place those on your number line. So 1 is here, and 3 is here. Now if you want to put 0, you totally can. This is a place value. You could have done that first. We need open circles, or hollow circles, if you will. And now we need to point. This says x is less than 1, so that's pointing to the left. This says x is greater than 3, that's pointing to the right. And since they're pointing in opposite directions, then our algebraic solutions stay separated just like you have them. For B, first we subtract 12 from both sides, and that'll get us a negative 3. Then we have to get rid of this negative sign. Now that's just like negative 1, so we have to divide both sides by negative 1. And when we divide by a negative number, our inequality has to change directions. So this will turn into positive 3. This is going to flip, and now the absolute value is by itself. This side's positive, so we're going to find two solutions. The first one is just to copy the absolute value exactly as you see it. And the second one is to change the 3 to negative and flip the direction of the inequality. Then you solve both of these. In the process of solving these, negative 3 subtract 6, I'm about to divide by a negative number. And since I'm about to divide by a negative number, the inequality has to change directions again. Subtract 6, that's negative 9. Divide by negative 3 changes the direction of that sign, so it's positive 3. So I have these two. I go to my number line. I'll put 1 on there. I'll put 3 on there. Again, open circles because the inequalities don't have the equal to. This says x is greater than 1. That's pointing to the right. And this says x is less than 3. That's pointing to the left. So we have a converging shaded area in this center section. And when that happens, we need to combine our algebraic solution to one sentence here. X is greater than 1. At the same time, it's less than 3. Okay, let me pause that. All right, I'm going to jump down and do D here. These are our quadratics that have the inequalities in them. So, first thing we need to do is move everything to one side so that the equation is equal to 0 so that we can factor it. So I'm going to rearrange this problem, keeping the 5x squared there, move the 22x over by adding it, sticking it in the middle, and then the minus 48 would go here. So our equation has 0. And then we factor this guy. Sometimes it'll be a cubic, so we're going to have 3 solutions, which maybe I'll insert here at the end. But let me go ahead and factor this guy. The fronts have to be 5x squared, so I got a 5x and an x. And my choices for 48, I got a 1 and a 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. So looks like it's going to be that 6 and the 8. So I'm going to put 8 here and 6 here. I've got 30 on the outside and 8 on the inside. I can make a 22 if the 30 was positive and the 8 was negative. So my solutions from these are 8/5 and negative 6. Those are the values I put on my number line. Negative 6 would be to the left and 8/5 would be to the right. This inequality means the dots that we make are solid dots. And now I have to test points in the sections I just created. There's a section to the right of 8/5, there's a section in the middle of these two values, and then there's a section to the left. And I need to test points to see if they make the equation true or false. And we're going to shade what's true. I always start with a number in between here, and a number in between -6 and 8/5 is 0. 0 is right about there. So I'm going to test 0. When I test 0, I use the pre-factored equation. So putting 0 there and 0 there is not bad. The only thing left is -48. Is -48 less than or equal to 0? Yes, it is, which makes this dot true. And if it's true, that means every dot between those would be true, so we shade those. Now, if I head over here to the right, since 8/5 is about 1.6, I can test the value 2. If I plug 2 into this equation here and 2 into this equation here, this would turn into 2. This would turn into 8. 2 times 8 is 16. 16 is not less than 0, so that's false. Plugging in -7 here, -7 here, this turns into -1. This turns into -43. And -43 times -1 is +43, which is not less than 0, so it's also false. So this is the location of our solution. Now, because it's converging, we make a sentence where we stick x in the middle. We copy these symbols here in this direction every time. Farthest to the left would go first, farthest to the right would go second, and that's our sentence algebraically in our graphic solution. Let's go ahead and slide over here to E. Moving everything over. Subtract 4x from both sides and subtract 12. We got to factor that. All right, so we factor this guy here. X, -6, x plus 2. So we're looking at the x value of 6 and the x value of -2. Those are the values that go on our number line, -2 and 6. We're looking at open circles at those locations. And now we test points. First point I test is 0, which is between these two values. 0 here and 0 here gives me -12 on the side. -12 is not greater than 0, so that location right there is false. Then I would test, maybe 7. And when I test 7, I would use the factored form. 7 right there and 7 right there. 7 right there would give me 1. 7 right there gives me 9. 1 times 9 is 9. 9 is greater than 0. So I'm going to shade everything to the right of 6. And then I would test, -3. -3 here, -3 here. That would give me -9 in this spot. It would give me -1 in this spot. -9 times -1 is 9. 9 is greater than 0. So that's also true. So I shade to the left. And since those are pointing outward, we make two individual statements. This is x's are less than -2. That was that guy. And this guy is x is greater than 6. And there's your two algebraic solutions for that, and then the graphic solution there. All right, I'm going to press pause. I'm going to find a cubic and include that in this video. All right, I hand wrote a cubic equation if you want to write that down. And if I recall doing this one earlier, required the quadratic formula, which was accidental. I mean, a quadratic formula is fine. It's just you get some terrible decimal answers there. So I'm going to avoid doing F right now. But don't panic if you have to use quadratic formula. All right, so this cubic graph or equation, we need to start by factoring. And the first thing you do in this one is to pull out the x from each of those terms. And then you're going to factor the remaining portion into binomials. And what that does is it creates three x value solutions. We got 0, and we got 4, and we got -3, and all of those need to go on your number line. So 0 and 4 and -3, and what that creates is 4 sections. This symbol here tells us we use open circle, and we have 4 sections we have to test points for, to the right of 4, and then in between here, and in between here, and to the left of -3. So it doesn't matter where we start. 0 is taken. I can't test 0 since it's got that symbol on it. So we'll go to the right of 4, which is 5. We're going to test 5, and I would use the factored form. So putting 5 in for all of the x's, I would get 5 times 1 times 8. And 5 times 1 times 8 is 40. Is 40 greater than 0? Yes. So we shade to the right of 4. And then I would test the x value 1. So plugging in 1 for all of these x's, I would get 1 times negative 3 times 4, which is negative 12. Negative 12 is not greater than 0, so that's false. So we don't shade in here. Then I would test negative 1. Negative 1 here would give me negative 1 times negative 5 times 2, which is positive 10, and 10 is greater than 0. So this location is true, so we shade in this little gap here. And then finally negative 4. Negative 4 here would get you negative 4 times negative 8 times negative 1. I'll write that so you can see it. Negative 4 times negative 8 times negative 1 is negative 32. And negative 32 is not greater than 0, so to the left of negative 3 is false. So here's our two sections. This section here, we would simply just write x is greater than 4. In a converging section, we use our sentence, x is greater than and less than. We put the farthest to the left here, farthest to the right here, and there's our algebraic solution.